Hello guys, welcome to Ramta Solutions and welcome to your lesson on grade 12 Euclidean geometry. Today we are looking at the Pythagorean theorem, which you famously call Pythagoras Theorem. Of course, it's okay, whichever you say, it's okay. So this famous theorem we all know. Now you're in grade 12. You have been saying it is the square on the hypotenuse of a right angle triangle is equal to the squares on the sum of the other two sides. This is what you've been saying all along. Okay? So, today we are going to prove this theorem. And the proof that you are getting today is the proof that you get in grade 12. However, there are many proofs to this theorem. So, let us say you are given triangle ABC with angle A equal 90 degrees. You must prove that BC, let's look at it, is BC the hypotenuse? Yes, remember, the hypotenuse is the side opposite the right angle. So BC squared is equal to AB squared plus AC squared. Now, let's get to prove this. First, let me just write proof. Okay, our proof. Now, I'm going to copy this triangle. Okay, copied. Let me paste it now. Okay, so what we know now, what we need to do first, we need to construct. So we begin with the construction statement. So for the construction, we will say draw AD perpendicular to BC. Okay, draw AD perpendicular to BC. All right, so let me take this guy here. All right, now this is A, this is B, this is C. So the statement says draw, let me use a red color. The statement says draw AD perpendicular to BC. Let me put him here. Right, let me put him here. So I'm going to call him, oh boy, sorry. I'm going to call him point D. Now, as you can see, we're saying draw AD perpendicular to BC. When we say perpendicular, you expect a right angle, right? So, because the statement given was saying angle A is 90 degrees, it wasn't saying angle BAC, it was saying angle 9. I'm going to separate this into 1 and 2, okay? I'm going to separate this into 1 and 2. Let me fix this one first. This was 90 degrees, right? So this will be 1, this will be 2. In the same way, this will be 1, this will be 2. So you have A1, A2, you have D1 and D2. Okay, perfect. So you have drawn you have drawn your triangle. Maybe I can squeeze it here. Let me squeeze my writing here. Okay, perfect. So you have drawn AD, which is perpendicular to BC, right? Now, what you know is this. I want you to look at it. I want you to agree with me that angle A2 plus angle C is equal to 90 degrees, right? Is equal to 90 degrees. There are many ways that you can say this is the case. If you're looking at this triangle here, these two must be 90 degrees. So you can say it's complementary for triangle CAD. However, it's also okay to say the reason could be sum of angles of triangle, let's say CAD. Okay? When you sum angles of triangle ACD, you will find that angle D2 is given, so obviously you will get 90 degrees. Okay, so maybe if you are a bit unsure, let me just show you here quickly. Angle, okay, just here, angle A2 plus angle D2 plus angle C is equal to 90 degrees for this reason. We don't know what is angle A2. We know angle D2 is 90 degrees. Angle C, oh sorry, not 90 but 180. Right, 180. Alright. Okay, therefore we can say A2 plus angle A2 plus angle C is equal to 90 degrees. Do you see it? Do you guys see it? Okay, perfect. Now this is not that important, but I won't erase it, so let me just continue with it. Now proceeding, we have said angle A2 plus angle C is equal to 90 degrees, reason being sum of angles of triangle CAD. Now I also see something here. Agree with me that angle A1 plus angle A2 is equal to 90 degrees. Do you see it? Angle A1 plus angle A2 is equal to 90 degrees. What's the reason? It's given, right? It's given. Look at it. They said angle A is 90 degrees. Alright? It's given. Okay. Now, when you substitute A2 into this, you will therefore find that angle C is equal to angle A1. Right? You will find that angle C is equal to angle A1. Right? Remember guys, this part here, it was just for you to understand how we got to this. This is basically what is happening in your Euclidean geometry. They expect your algebraic expressions or your knowledge of solving things algebraically to be on point. Alright? So now if you are unsure as to where I got this from, I'm gonna explain again. Remember that for presentation purposes, the black color is the one that we need. Now to explain, I'm saying A1 plus A2 is equal to 90. If you say A2 is equal to 90 degrees minus A1, and you substitute this into, say, into this equation here, what do you get? You will get 90 degrees minus A1 plus C is equal to 90. And if you solve it, you will get this. Can you guys see it? If you solve it, you will get this. Can you guys see it? Okay? If you solve it, you will get this. Okay? Happy? Now, proceeding, we are then going to look at angle, let's look at angle B. Angle B plus angle A1 must also give us 90 degrees. Let's go back. Angle B plus angle A1 must also give us 90 degrees. Why? It's simply because this is sum of angles of triangle ABD. Okay? This is because this is sum of angles of triangle ABD. Right? In the same way, we have A1 here. If we rearrange this equation here by equating A1 to 90 minus A2, we will get, let's say, therefore, we will say angle B is equal to angle A1. Happy? Right? Angle B, let me confirm. No, angle B, no. Angle C is equal to A1, that's correct. Oh no, here we are saying A1, so it'll be A2, pardon. It'll be A2, yes, it'll be A2, right? It'll be A2, right? So, angle B is equal to angle A2. So we have been able to prove this. However, we are not done. There's something that you should see. I want you guys to see this. Angle A must be equal to angle D1 Of course, you expect angle D1 to be 90 degrees because it's perpendicular. AD is perpendicular to BC. So is equal to angle D1. It is also equal to angle D2, which is equal to 90 degrees. Yes, A is equal to 90 degrees is given, but D1 and D2, you got it by construction. So let's just say generally by construction. Therefore, let's look at, let's start with triangle ABD. Triangle ABD is similar to, I'm gonna take the main triangle. Okay, I'm gonna take the main triangle. Triangle ABD is this one here. Can you see it? This is the hypotenuse. What is the hypotenuse? Angle D1, which in this we will say it's basically related to D. So leave a space a bit. It'll be D. Sorry, it'll be B, not D. Wait. Here, when we compare it with triangle ABC, this 90 angle D1 corresponds to angle A. So at the end it'll be A. Okay, at the end it'll be A. Leave a space for the others. Now, ABD and the main triangle ABC, they share an angle B. So let's look where angle B is. Okay, it's in the center. Therefore, it means this one must be C. Alright? The main one is angle C. Alright? The main one is angle ABC. So these are corresponding. Alright? Angle A corresponds to angle C. Is that what we said? Angle A in ABD. Where is it? Angle A in ABD. Here is it. Angle A in ABD. Here is it. Corresponds to angle C. Okay? Perfect. Obviously, B is common. So you see the dot I'm putting here is to say these are corresponding. Alright? Perfect. Now I'm done with ABD and CBA. Let's also equate it to, rather, it's also similar to triangle. Let's take CBA and let's call it ADC for now. We don't know the order, but we will find the order. CBA and ABD. Now, what we know so far is that angle for CDA here and ABC, we see that angle C is common. Can you guys see that? Angle C is common. Oh, so since angle C is common, it means this one, I must start with C. Again, we have a 90 degrees here, which is D. The 90 degrees we had in ABC was A. So D must correspond to A. So where is it? D must correspond to A. What did we say we're looking at? CAD. So obviously, it'll be CAD like that. Alright? It'll be CAD. Now, what did we say about this one here? What we had said as well was that angle A2, look at it, angle A2, let me change the color, angle A2 was equal to angle B. Let's go back. Was equal to angle B. Do you see this? So now, this strategy is what will help you whenever you're using Pythagorean theorem. Okay? But you will see later that it can be done easily. Okay? You will see later that it can be done easily. So remember, for similarity, this is what we do. Now, why do we say these are similar? This is simply because corresponding angles are equal. Alright? This is because corresponding angles are equal. Now, from that fact, we can therefore say AB over, let me see, AB, as I see, AB is a hypotenuse on triangle ABD. Can you see it? Is the hypotenuse because it's opposite the right angle. So I will compare ABD with the main triangle. I think we called it CBA. Alright, we call it CBA. When I compare it to the main triangle, The hypotenuse of the main triangle is BC. So remember, pairs of corresponding sides. So AB over BC is equal to, let me perhaps take BD. I'll take BD. Here's BD, right? BD. I want a side that corresponds to BD. Let's look at it. I want you guys to pay attention. A side that corresponds to BD is like this. This is your 90 degrees, and that side is the one that has an X next to it. So for the main triangle, it cannot be AC. The one that corresponds to BD, it'll also be the one that this angle lies on. So it'll be AB. Okay? So it is BD over AB. What's the reason? The reason is that we said triangle ABD is similar to triangle CBA. Okay? It's similar to triangle CBA. Having said that, you can see that we have AB, so we can therefore say AB squared. When you multiply throughout by AB and by BC, you will find that AB squared is equal to BD times BC. Can you guys see that? Okay, perfect. Now I will then take similarly we will say, let me write it, it's okay even if you don't write it. Similarly, we will say the other side that I didn't take on triangle ABD, the other side that I didn't take, ABD, okay, let me take this one because we're looking for AC. Let me take AC, so I'm gonna be here, so I'm gonna take AC. Okay, yeah, let me just take AC. Why I'm saying this, guys, is because we're looking for AB squared plus AC squared, so I have to take AC. I have to take AC here. Okay, I have to take AC here. Now AC to the main triangle, AC to the main triangle, AC to the main triangle corresponds to, AC is basically the hypotenuse to triangle CAD, alright? Yes, CAD is basically the hypotenuse to triangle CAD. What does it correspond with? It corresponds with BC in the main triangle. Or should I say CB? It doesn't matter. Maybe, yeah, I said AC. Let me call it BC. It doesn't matter. Okay, even if you call it CB, it's okay. So I will call it BC. So over BC or CB, it doesn't matter, is equal to another side that I can compare it with. Maybe let me compare with DC. Yeah, I'm gonna compare with DC. Alright, I'm gonna compare with DC or CD. Let me call it CD. Okay, I'm gonna compare with CD. Okay, so CD, let's see, CD over, let me see, or should I say DC? Doesn't matter. Okay, let's look at it. DC. So when I look at DC, it's sleeping on this angle here and the hypotenuse. When I look at what I need on the main triangle ABC, it looks like it is corresponding to what we call AC or CA. Alright? Can you guys see that? So this is AC. I'm going to write AC. So it corresponds with AC. Therefore, what do we have? As you can see, AC cross multiplication. We will have AC squared equals CD, or let me call it DC. DC times BC. Okay? DC times BC. Okay? So this is AC squared. Okay? So we were able to find AB squared and DC squared. When you look at it, this is what we're supposed to prove. We are able to find this, but can the sum of this give us this? Let's see. So AB squared So therefore AB squared plus AC squared will be, what is AB squared? It was BD times BC. Let's go. It was BD times BC. What is AC? AC is this one here. It is DC times BC. Now, as you can see, you have a common factor BC. Take it out. What are you left with? You are left with BD and DC. Now, BD and DC, let's see, to our triangle, BD plus DC. What does it look like? BD plus DC. Doesn't it look like BC? Indeed, it is. Right, it is. So this is BC times BC. What are you left with? You are left with BC squared. Therefore, therefore, BC squared is equal to AB squared plus AC squared. Now, you have proved Pythagorean theorem. Okay, you have proved Pythagorean theorem by using similarity. Okay, by using similarity of triangles. Okay, all right. So this is it, guys, and I hope you are having a blast. So with that being said, it's a wrap, and bye bye.